I really appreciate the opportunity to talk with you today a little bit about strategies for alfalfa production during low water years. My name is Dan Putnam. I'm at the University of California at Davis. I'm statewide extension specialist for alfalfa and forage crops here. And this is my website on the screen, on my email in case you need to reach me. We also have an alfalfa blog which you might be interested in signing up to. We have periodic postings there about many different issues associated with water as well as alfalfa and forages. Oftentimes I think it's tempting for growers when they're faced with a drought situation or lack of water for their farms, whatever the source, to curl up into a fetal position. But I think that there are some opportunities here for alfalfa to cope with these kinds of difficult years. It actually has some advantages compared with other seed-producing crop and fruiting crops for low water years that we'll go over here. And there are some possible responses and strategies to cope with these kinds of difficult years that growers often face. In many areas are very common, but this year is going to be pretty much many sections of California. Irrigated alfalfa is actually fairly important in the United States. About 40% of our U.S. alfalfa is produced in irrigated regions in the western United States. California is actually the #1 producer of alfalfa in the nation, alfalfa hay in the nation. And also it's the #1 acreage crop in California, so it's got a fairly sizable footprint here. And oftentimes alfalfa in many states is the #1 water user in western states. So it is actually an important crop when it comes to irrigation systems. It's also the basis of a food producing system, which oftentimes people forget. In other words, we take water and soil, produce forage crops or other types of crops that are fed to dairy cows, and produce food products that are recognizable in our daily lives. California produces about 21% of the nation's milk, and that's where most of our alfalfa goes. The productivity is very high for alfalfa. We produce the equivalent of about 2,400 gallons of milk per acre on an alfalfa field. And so it's important to realize that this is a food producing system. It's also a question of value. It's worth about $1 to $1.2 billion per year for the alfalfa crop, and dairy production, which is closely allied with the forage system here, is about $7 billion per year. But there are also a range of other animals that depend upon alfalfa: horses, sheep, goats, beef animals. It's clearly one of the most important, if not the most important, food-producing system in our state of California. It's also important to remember that water is not just one resource that a plant needs. It's actually should be considered the driving force for alfalfa, for plant growth and yield. This photograph here shows the stomata underneath of a leaf, which is required to be open in order for CO2 to enter the cells and produce photosynthate from photosynthesis. And so water comes from the soil through the plant through turgor pressure and evaporates off the surface of the leaf, providing the energy that the plant needs for cell expansion, the integrity of their cells, and for photosynthesis to allow gases to come into the leaf and be converted into sugars. And so it's important to remember that once that turgor pressure or the wilting of the plant occurs, growth essentially stops. So water is not just simply something like we require water as well as food, but it's actually a driving force along with sunshine and photosynthesis for plant growth. And irrigation management, that is the either deficits or lack of irrigation water, excess irrigation water or lack of uniformity, limits alfalfa yields more often to a greater extent than really any other management factor for alfalfa. It's true with many other crops as well, but particularly with alfalfa. But alfalfa has some important advantages with regards to water. First of all, it's high in water use efficiency. That is, the yield per unit water is very high compared with many other crops. It's a perennial, so it starts early. You don't have to plant it every year or irrigate it for periods of time until it reaches full canopy. It can take advantage of winter rains. It has very deep root system, which means that it's difficult to water past the root zone. It accepts degraded water and cleans up particulates and nitrates from degraded water, unlike many crops which it's very difficult to use, for example, wastewater for fruits and vegetables or for trees. With alfalfa, that's actually quite feasible. It's also a crop which contributes a lot of wildlife habitat due to the fact that there's water on the surface of the soil and a good habitat for birds and other kinds of wildlife. And it also has the ability to be deficit irrigated or irrigated less than the full needs. So this ability to be deficit irrigated is actually one of the strengths during a low water year, which many fruits and vegetables cannot. This is really not very feasible because they require seed production, whereas alfalfa is a herbaceous plant and does not require fruit or seed production. So what are our strategies for dealing with this kind of drought situation? Well, I would organize them this way. First of all, we need to triage or try to figure out which fields are not worth continuing to produce under these kinds of low water situations. What are how can we increase yields, particularly through longer cutting schedule management, better crop management? Can we use lower quality water and move better water onto other crops? And can we increase our irrigation management? And can we do some deficit irrigation or water less than the full needs of the crop? So I'm going to cover some of these issues. And the principle here is that we're going to look for strategies to increase the amount of crop production per application of water, more crop per drop. So in old stands, these are clearly in a water short year are stands that we should consider either letting go or doing something with. We could overseed these stands with more productive forages. For example, in the early spring, we could put in oats, ryegrass, or cool season grasses, or perhaps Sudan in the summertime if that is going to be a higher yielding option. But many of these may have to be fallowed in this kind of situation, perhaps after one cutting in the spring. And generally, we would recommend that if the stand is down below 4 to 6 plants per square foot, you should consider letting those stands go if you're short on water. And actually, even if you're not, I think those are questionable stands, and maybe even a little bit higher stand count might be candidates for fallowing that particular year. It's actually more important to look at the numbers of stems per unit area, and when we get down below about 40 to 45 stems per square foot, we tend to see lots of decline in yield. So those are candidate fields that we ought to look at. We should look at the root health and the likelihood of persistence of that field, and it's probably a better idea to move that water over to other fields in that kind of situation. We also should look at longer cutting schedules and crop management strategies for improving yields. Remember that in a high-priced year like this year is likely to be a high-priced year because the supply of hay is going to be lower, favors yield over quality. Longer cutting schedules, we know, can increase yields up to 2 tons per acre. That's what our data says. And we need to intensify the water use on these good fields, and it's better for the plant. It's better, you have less traffic, better root reserves, and of course less harvesting expense. Again, we're back to this idea of more crop per drop. This is an example of the change that's due to yield and water use efficiency. These are the yields over the last almost 90 years in California. We've leveled off over the last 20 or 30 years, but we've certainly increased yields quite substantially, and as a result, we've increased water use efficiency. Also, these are cutting schedule effects on yields. The yields, as we increase the number of days, go up, and the quality goes down, but the yields go up. So here we're talking about 2 tons per cutting, and here we're talking about 5 tons per, half a ton per cutting. And so that's a really big difference, and we need to look at perhaps sacrificing some quality in favor of yields in a year like this. This is some data that shows that over a 3-year study that we had at UC Davis, you can increase yields at least, it's about 2.5 tons here. You do get lower quality, but I think in a year like this, tonnage is going to be much more important than quality. We can also use or consider using lower quality water if that water is available. Alfalfa is pretty tolerant of manure waters and municipal waste waters, and at least some salinity if saline waters are the only waters that are available. High nitrate is actually not too big of a problem for alfalfa, and particularly under established alfalfa, it can likely sustain a high level of salinity than perhaps we previously thought. This is some data showing under greenhouse conditions that you get 75% of the full 75 to 80% under tolerant lines, even up to an EC of about 15 on greenhouse studies. And there's a big variety difference here that we have to pay attention to. And these are some yield trials at Westside Field Station where we irrigated the trial over a 3-year period and saw yields averaging about 12 tons per acre with saline well applications with an EC of approximately 5.5 over that 3-year period. But we need to look at managing salinity, of course, in fields, and that's really a critical issue. Leaching fraction, we have to pay attention to the use of gypsum, organic matter and aeration, as well as resistant varieties might all be important. This is an important subject in its own right, but alfalfa probably has not been given credit for being able to be produced under saline conditions, and I think there's more opportunities there than perhaps we've given it credit for in the past. Other strategies for dealing with these kinds of low water years, we need to look at better irrigation management, obviously. That is particularly matching ET with irrigation applications and following it up with soil moisture monitoring. These are the principles of good water management. ET is simply the sum total water demand by a crop and soil in a region, and a function of both the evaporation and transpiration through the crop. That is, evaporation off the soil surface as well as transpiration through the stomata in the leaves. What factors drive evapotranspiration? Well, solar radiation is probably one of the most important. Temperature, canopy structure, stomatal resistance, that is degree of stress of the plant and the leaf area. The differences in humidity, boundary layer, for example, wind effects are also very, very important. Here are the differences in ET over the season from a low of about less than 0.1 inches up to a high of about a third of an inch per year, particularly, in fact, you get even higher in the low deserts, maybe even close to 0.4 of an inch per day over the season. But in the cooler regions, of course, it's not quite so high, but you get certainly much higher ETs in the summer, lower ETs in the spring and the fall. And this is an important thing to consider when we're looking at irrigation strategies. How much water does alfalfa really need? Well, here's a recent summary that Blaine Hansen conducted with myself and quite a few other colleagues, looking at field measurements over the state ranging from 57 to 65 inches down in the Imperial Valley, low desert, in the sort of low 50s to mid 50s or upper 50 inches in the San Joaquin Valley and Sacramento valleys, and closer to 3 feet of water in the Scott Valley, Shasta Lake area, Tule Lake area of Intermountain, California. But we have to consider that soils are what provide water to the plants. So we need to understand how much water is being held in the soil. So these are good, important principles of irrigation management. We have to look at the soil as a water storage containment. And remember that only 50% of the water in the soil is typically available to plants. And alfalfa roots often grow to about 3 to 4 feet deep or more in the soil. So we have to consider the rooting depth. I would generally consider the rooting depth of alfalfa to be about 4 feet, but a lot of the action, of course, is in the top foot or two of the soil. And each soil has a different water holding capacity, and these are estimates for the top 4 feet of the root zone for a sandy soil all the way up to a clay or even an organic clay loam, which has tremendous water holding capacity. But most of our soils will not hold 16 inches. It's typically closer to 4 to 6 inches of water in the root zone, and so we need to irrigate considering how much water there is stored. And typically the idea is that you calculate the ET charge to the soil day by day and estimate that daily ET and understand that you need to only allow about 50% depletion, and it answers really when you should irrigate and when you should and how much you should irrigate. And here's an example. For example, we have these are in millimeters, 6.5 millimeters in this day, 6.8, 7, and so forth. You accumulate this loss in irrigation in water, and then you apply irrigation water and then reaccumulate that loss, and that will tell you when to irrigate. Remember that ET is really very closely related to yield in alfalfa, and so regardless of where you are, the ET will drive yield, as I mentioned before. However, there are these periods of harvest which are really difficult to deal with, and so as a result, a lot of people don't really think about the ET as much as perhaps they should. This data shows the loss in ET during a cutting situation, and you see this going down and going back up again, and that's actually what's happening during a cutting period. So you have this lower ET and then a higher ET situation that takes place during the cutting season. So the weather-based irrigation strategy works pretty well, except that it's not used very often. Growers should probably pay a lot more attention to it than they do. It's difficult, however, to schedule around the harvest, and there are logistical issues involved here as well. So we recommend that we look at soil moisture monitoring using something simple like electrical resistance blocks. For example, these watermark blocks here, and this gives you information about the drying rates of the soil, and you can see here that the top soil here is drying down, and then we irrigate, and then it wets up again, and then it dries down again, and we irrigate, and it recovers moisture, and then we irrigate a third time, and it recovers even back up to a fully charged profile. It's been my observation a lot of growers don't know what's going on down below the soil, and in a drought year like this, you really need to know where the water is located, how much water you have at different layers in the soil. Here's an example of somebody who's really dried their field down substantially. They have never really recovered soil moisture over the year, and here's an example of somebody who's overwatered their field. So you have a situation where this person could have skipped this irrigation and perhaps even this one over this period of time, and without knowing where the water is in your soil, you really wouldn't know that. So we need to do a better job of monitoring in these alfalfa fields, and we need to ground truth our ET estimates. We do have a booklet and a spreadsheet available on this issue. So the last thing I'd like to talk about is summer dry down in alfalfa, that is regulated deficit irrigation. The logic here is that the ET, or the water demand of the crop, is really the highest in the summer periods. We get maybe 50 to 60% of the water use in mid to late summer. Yields are moderate during that time, quality is often low, water use efficiency is the lowest during that time, and economic returns are often moderate or low during the summer months. So is it possible really to stop irrigation during this period and rewater in the fall? And we've been doing work at UC Davis and those cooperative extension around the state of California for the last at least 10 years, probably more like 15 or 20 years on this issue. And this is really an important strategy. And this is some data from my variety trials, or UC variety trials, showing that by mid-June, about 50% of the yields of alfalfa on the average, this is a number of years worth of data, is realized by mid-June, and by late July, we get up to about 75 or even 80% of the yields of the year are realized by that time. So that means that in August, September, and October, we may be able to forego 20 to 25 or 30% of the yield of that crop by stopping irrigations. And this is also in the Kearney station, which showed exactly the same result, that we get about 50% of our yield by mid-June and 70% by late July. And same at Davis, we get about 75% by late July in Davis, California. So typically 50% of our seasonal yield is achieved by mid-June. We get 70-75% of full yield by July 31st. And this is during the time of the highest water use efficiency for alfalfa, and it declines basically after this period of time. So the idea here is that can we stop irrigations during July, August, and September, and by doing that achieve this concept of more crop per drop? And the answer is generally yes. The other thing we have to consider is that forage quality is actually lower during these summer months, these hot periods in the summer, and we also get a penalty for lower quality hay during the hot summer months, say the 5th and 6th cuttings than we do, 4th, 5th cuttings than we do earlier. So we've done a whole series of research projects on this issue in Blythe, Imperial Valley, Low Desert, Fresno, San Joaquin Valley, Colusa and Yolo County, and Sacramento Valley, and the Intermountain area. I'll just talk about the valley experience here. So in general, deficit irrigation reduces yield in most cases versus full irrigation, depending upon the water table contribution. In some cases, you get actually a pretty significant water table contribution in the late summer. But basically, it goes into a drought-induced summer dormancy. And in most cases, alfalfa stand is not compromised, but in some cases, we do see damage, and we can talk about that a little bit. We can reduce our water needs by 1 to 3 months by doing this. A full irrigation early followed by periods of dry down may be better than what I would call a starvation diet, where we deficit irrigate every cutting. So here's some of our early results in the 1990s from the Imperial Valley, with 3 irrigations in July, August, and September reduced down to 0. And we see a yield penalty here, showing here with minimum stress, we get about a half ton yield penalty. And also on longer stress, of course, we'll get the greatest yield penalty. And not too surprising. The question is, what's the effect on stand? Well, we do get Imperial Valley and Blythe is where we get the biggest losses in stand. But then again, we do get a big loss in stand anyway, even under optimum irrigation situations. So it's one that for Imperial Valley, we might have to consider overseeding to reduce, after a deficit period, to increase the stand after of deficits. Same result in Blythe. We saw stand reduction in Blythe, but in the other locations, we haven't really seen that much stand problems. We've also had trials in the Central Valley part of California where we had wet stand. This is Carroll Freight's data from standard irrigations to 1 per cutting, and different kinds of cutoffs here, a July-August cutoff or a July termination. And not surprising, again, we have a reduction in the amount of water that's required during that time. So you see in the 3 different years, the reduction in water during that time, except for the last year. And we'd also see, again, not surprising, reduction in yield. But the reduction in yield is not 0. And this is really the point, that alfalfa really is forgiving in the sense that you can still produce a crop with deficit irrigation, which is not true with many of our fruiting and seed-producing crops, where we get almost complete, in many cases, complete crop failures under severe deficits. So we have standard irrigations yielded the best in this trial. However, the alfalfa was able to withstand severe droughts and recover when irrigated fully afterwards. And that was actually generally in most locations was our result. And this shows a photograph of the fully irrigated fields here and the deficit irrigated fields here. No irrigation since the end of July. Alfalfa actually continues to grow to some extent during that period of time, which is in some cases if you have a high enough water table. If you don't, then it really goes into an induced dormancy. And here are some of the yield results from our Sacramento trial showing these lower yields in the late part of the year. But then the next year we don't really see that big of an effect on the following year's results. Imperial Valley, it goes into more of an induced dormancy. You can see that sort of brown effects in the fields, but the following year we saw fairly normal yields. So the yield reductions really are highly variable depending upon where you are, but we do see reduced yields under deficit irrigation. How much water can you save? Well, it's somewhat controversial depending upon how you calculate it. It can be considered essentially the applied ET, that is the amount of ET which is not supplied through irrigation water after irrigation termination. For example, the normal irrigation practices between August and September and October. Or you can calculate it as the difference between the fully irrigated and deficit plots, since some plant growth and transpiration does occur during that period of time. These are some of our calculations for the inches that are saved. That is the differences between fully irrigated and the deficit irrigated alfalfa. However, it's our belief that, that in terms of our thinking about this issue, that since water that is not irrigated to an alfalfa crop, say during July, August, and September, is available for use on other crops, that is, it's water that's not applied during that time, we would recommend using the ET from a point of irrigation termination through the end of the year, which is typically in alfalfa is usually in late September, October, depending upon, or even November, depending upon the location in California. So we do have desiccation of alfalfa plants, and we do see root pruning and loss of feeder roots. We do see depletion of carbohydrate reserves and some salt accumulation, but in general, alfalfa is tolerant of these extended drought periods. You know, it really is kind of an interesting phenomenon because it did evolve in areas that were characterized by long, hot, dry summers. Losses are probably going to be greater under situations where you have severe cracking in heavy soils, and on sandy soils where you don't have much water available during very, very hot periods. So there's an opportunity here to save significant amounts of water with deficit irrigation. No surprise that yields and gross returns are probably going to be reduced, but the profits will depend upon lots of factors. We do see stand losses in our desert environments and on certain soil types, and yields generally can return to normal if the stand survives. So in summary, opportunities to cope with a low water year may include the following. We need to think about triaging or eliminating fields which are no longer productive. We need to think about longer cutting schedules and lots of different crop management techniques, including pest management, to improve yields. We need to learn how to use degraded water because alfalfa is actually fairly tolerant of degraded water. We need to improve our irrigation management, which I think is something that all farmers need to pay attention to even in a high water year, but especially in this type of year. We need to look at regulated deficit irrigations that as summer dry down under low water supply years. And longer term, I think we really need to improve our irrigation management systems. That is, consider pivot sprinklers, buried drip, and improved surface irrigation systems for alfalfa, but that's not something that's easily done in a single year. It's something that growers have to consider what's better for their particular soil type and their water supply situation. So anyway, I appreciate it. You're welcome to contact me. At the very beginning here, I gave my email or a website, and we'll try to post as many things about water on our blog. And you can just Google alfalfa blog, and it usually comes up, and take a look at what we've posted at those sites. Thank you very much. Appreciate it, and wish all of the growers here luck in this low water year.